Hi, this is Andrea Hendricks. Let me show you how now you can use reference angles to evaluate trig functions. So remember, the reference angle is the acute angle that's formed between the terminal side of the angle and the horizontal axis. So we'll call that theta prime. Well, why is the reference angle so important? Well, it's so critical because the reference angle and the original angle have the exact same trig values except for possibly the sines, and that is because the terminal side of the original angle could lie in quadrant 2, 3, or 4, so we know the points on the unit circle xy will be different depending on which quadrant that point happens to lie in. But if we can get it back in terms of the reference angle and know which quadrant it's in, we can know immediately the trig values of that angle. So, and I won't show you this again. I showed you before where if we make this in terms of a right angle and show what the trig values would be of that angle theta prime, we would get the same as what the original angle are. So we have the same trig values without considering the sines right now. So that means that it's important for you to know what those reference angles are in the first quadrant, okay, because our reference angle is acute, so it's going to be a 30, 45, 60 degree angle. If you know what their trig values are, that is the points on the unit circle, then you're going to have this made. So the most difficult part then is going to be finding the reference angle. So if you can find the reference angle, okay, then think of it in terms of an angle that's in the first quadrant, then determine what the sines of your angle would be, the trig functions of that angle, and then you have it made. So let me show you an example. So, and again, let me back up for just a minute. You could plug all these into the calculator. That's not what I'm testing, is your ability to plug into the calculator. You can certainly use a calculator to confirm your work, but on a test or quiz I'm going to want to know the exact value of the trig function. So, I mean, using the calculator would not help you in that regards, because then you would have to turn everything into either the square root of 2 over 2, the square root of 3 over 2, whatever, to figure out what that would be. So let's think about an angle that's 495 degrees. How are we going to find the sine, cosine, and tangent of that without a calculator? So if we think about on a coordinate system, where is that angle? Well, we know it makes a full revolution of the circle, right, is 360. And if we go 360 plus 90 more, we would have gone 450. Okay. Well, we're not going to go 90 more because that would take us beyond the 495. So 495 is going to be here. So what is that in terms of the reference angle? Well, we can think of that if you want to in terms of what would we have to go to make up coming over here to the horizontal axis. So if we think about what's 360 plus pi, or I shouldn't say pi in this term because we're in degrees, let's say 360 plus 180 is 540 degrees. So our reference angle in this case, that is our theta prime, it's going to be 540 degrees minus 495 degrees. So 540 minus 495 is 45 degrees. So our reference angle is 45 degrees, so that means that 495 degrees is going to have the same sine, cosine, and tangent as 45 degrees, with the exception of the sines. Since this lies in the, second quadrant, we know that it's going to be a negative x and a positive y, which means our cosine is going to be negative and our sine will be positive. So the cosine of 495 degrees is going to be the negative of square root of 2 over 2. The sine of 495 degrees is going to be the square root of 2 over 2. And the tangent of 495 degrees is sine over cosine, which would be negative 1. And you can check if you want to put your calculator mode in terms of degree, and then go to tangent of 495, and you see that's negative 1. You can certainly do the sine of 495, and you get 0.707, which is a decimal approximation for the square root of 2 over 2. We do the cosine of 495, you get negative 0.707. So that confirms that we've done everything correctly. But if you have that unit circle memorized, then you don't have to even pick up the calculator if you can find the reference angle okay. Now, what about negative 4 pi over 3? So negative 4 pi over 3 is negative 1 pi over 3, negative 2 pi over 3, negative 3 pi over 3, negative 4 pi over 3. So it's going to be in quadrant 2 as well. Okay. Well, if you want to think about a positive angle that has the same terminal side, that would be 2 pi over 3, right? Because we think about what makes up a full revolution, and that would be 2 pi over 3 is what we're lacking. So we could also think of that in terms of 2 pi over 3. Now that's only in terms of getting the reference angle, okay, if that makes it a little bit easier for you. But our reference angle then in this case is going to be the acute angle between the terminal side and the x-axis, right? So you can think of it like this. Theta prime is going to be pi minus 2 pi over 3. Okay. And that's going to be 3 pi over 3 minus 2 pi over 3, which would be pi over 3. So that means that the sine, cosine, and tangent of negative 4 pi over 3 are the same as the sine, cosine, and tangent of pi over 3, except for the sines. So we need to think about this. Again, in quadrant 2, the cosine will be negative and the sine will be positive. So the cosine of negative 4 pi over 3 is going to be the same as the opposite of the cosine of pi over 3. If you need to, go back to your unit circle. Pi over 3 has a cosine of 1/2. So that means the cosine of negative 4 pi over 3 is going to be a negative 1/2. What about the sine of negative 4 pi over 3? The sine is positive, so it's going to be the same as the sine of pi over 3, which would be positive square root of 3 over 2. And then the tangent of negative 4 pi over 3 is sine over cosine, so that would be a negative square root of 3. So again, you can use your calculator if you wish. Make sure your mode is in radians this time. And if you find the tangent of negative 4 pi divided by 3, you can get negative 1.732, which is a decimal equivalent of negative square root of 3. The cosine of negative 4 pi over 3 is negative 0.5 or negative 1/2, and the sine negative 4 pi over 3 is 0.866, which is a decimal equivalent of the square root of 3 over 2. So you can check yourself out with that. Now, what about negative 17 pi over 6? Where in the world is that? Well, if you think about negative 17 pi over 6, that's almost negative 18 pi over 6, right? Negative 18 pi over 6 would be a negative 3 pi. So what we're doing here is thinking about going one full revolution around this negative 2 pi and almost a negative pi. So negative 17 pi over 6 is going to look like this. So what would be our reference angle here? We can kind of think about it, right? If we went one more pi over 6, we would be at the horizontal axis. So theta prime in this case is going to be pi over 6. Now, if you want to think of it in terms of how can I write this as a subtraction, I could think about that as really 18 pi over 6, if you will. Right? And I need to think about how far am I from 18 pi over 6. So 18 pi over 6 minus 17 pi over 6 would be pi over 6. Now, when we're in quadrant 3, we have negative for sine and cosine. Tangent would be positive there. So now we could figure out what cosine, sine, and tangent are of this angle. So the cosine of negative 17 pi over 6 would be the opposite of the cosine of pi over 6. And again, if you need to go back to your unit circle, you can. Cosine of pi over 6 is the square root of 3 over 2, but I really hope you get these memorized. So that would be the negative square root of 3 over 2. Tangent of negative, I'm sorry, not tangent. I can go ahead and do that, I guess, but I was really wanting to do sine. Sorry about that. Sine of negative 17 pi over 6 is going to be the negative sine of pi over 6, which will be negative 1/2. And then the tangent of negative 17 pi over 6 is sine over cosine, so that's going to be a positive 1 over the square root of 3, which is square root of 3 over 3. Okay? So the tricky part is, again, really finding that reference angle. Once you get that down, everything is in terms of the first quadrant angles from the unit circle. So think about how far are you from that horizontal axis. So either how far are you from pi, or how are you from 2 pi. But then you may need to do multiples of pi or 2 pi as you have more rotations to go around. Okay? So if you have any questions, please don't hesitate to contact me. Thanks.